So really happy to see everybody here today. To introduce myself, my name is Richa. I'm from Google. And today, we're going to be actually having our FHIR Implementers Showcase. So I'm really excited to be able to have this opportunity to introduce to you some of our implementers in the ecosystem who are really looking forward to sharing some of their work here. And the intention behind having this showcase is really for them to be able to talk about some of the use cases, some of the challenges and the problems that they had individually faced, that they saw challenges in the ecosystem that they felt needed to be addressed. And so the question was, how did they address these challenges by using FHIR? So this is not so much about product pitch, but rather more about how do we think about using FHIR to address specific problems and use cases. So I'm really looking forward to seeing some of the presentations that we have coming up. Following this session, there will be a product demo right outside. And so we look forward to having our presenters here further share some of their platforms and products that they have built using FHIR. The other thing that I was just made aware of, and no pressure to the presenters, I'll be coming up on stage shortly, is that at the end of this, we do encourage everyone to vote on the best presentation, and the one that gets the most votes gets a prize. So the idea here is not really about it's really about just making sure that everyone is engaged and listening and is interactive. Feel free to ask questions. And like I said, we have the product demo following this, so there's more time for discussions later as well. So without further ado, if Sylvia, if you can help me advance the slides, I'd love to be able to talk through the presentations that we have today. So these are really lightning talks, 5 minutes, to really talk about each of our presenters sharing what they do, the problem that they faced, and how they used FHIR to approach this. We will be quite strict about time, simply because we have a lot of people who will be coming up here on stage. And so to our presenters, just a reminder that you have 5 minutes, and we will have a time check at the back, just signaling when you have a 1 minute to end. And so without further ado, I would like to invite our first presenter from PSI to come to introduce themselves and take it away.
Thank you very much. My name is Moses Jinga, Senior Manager Digital Health Solutions from PSI. And I'm excited to share with you a collaboration that we've done with the Ministry of Health Kenya. This is a unique solution because it is consumer-facing. And the solution is called Jali. So at the height of the pandemic, we received some funding for COVID programming. And as PSI, we've had a lot of experience implementing digital health solutions across different regions and across various health areas. And out of that experience, we understood very well the limitations of siloed implementations in terms of scaling, how people can be able to reach, and how can your solutions scale well enough to be able to address a big scale. And then number two, in terms of sustainability. A lot of what we do is guided by the donor timelines. It's 2 years, between 2 years, and then you have to wrap up. So once we got this funding, we got thinking, how can we make sure that we do this implementation in a way that can scale and in a way that is sustainable? And therefore, we had to ask ourselves these questions. Should we continue doing what we've been doing and implement this internally at PSI, or should we look for a collaboration to make sure that we can be able to scale? The next one is, should we just concentrate on COVID, which is what the donor would like us to do, or should we scale this a bit to make sure that we address a bit more number of people? So we got through these considerations, and therefore we partnered with the Ministry of Health Kenya, looked at how they do their health communication to make sure that we can be able to address those issues of scaling and those issues of being able to reach a big number of people and doing it sustainably. So we started the Ministry of Health and asked ourselves, how can we design this solution to address those areas? So number one, we decided to use a consumer-facing tool which is used by everyone. So the thing that people think about, let's do an Android app, or let's do a web application or a progressive web app, but we have to look at who is the audience, where are they, what are they using. So our selection was WhatsApp because it's used by more than 11 million people in Kenya. And then the next stage was to think about what applications do we use to build this tool. And we selected tools that are open source and that use open standard to make sure that once we do this with the Ministry of Health and they host it in their own data center, they can be able to maintain it going forward. And therefore we selected RapidPro, which is very used in the health sector, OpenHIR as well everywhere, FHIR for storage of the conversation data, and for visualization we use OpenPros, NiFi, Postgre, and Superset for visualization. So in terms of the FHIR resources that we use, and this is quite important, if I go to the next slide, we have used these resources, and it's important because it helps us be able to partner with other people in the health sector. So number one, we use the patient resource, of course, to represent users who are interacting with the chatbot, and we collect the attributes as users interact. Sometimes to the anonymous user, we no identifier. Maybe that person needs to be referred to a health facility, so we need to know who they are, the name, their location. So that's how we build the patient. Then consent, of course, we need to be able to know how the user wants us to share their data. So we have consent to our terms of use, privacy statement, and because we look forward to having other implementers using the fundings they get to support the Ministry of Health, we have other organizations that might maybe want to do research or have funding for another health area, and therefore they can be able to bring in their consent and be able to collect data that they require within the need of the program. So we are using question and response to capture conversations and communications for nudges and notifications. Then in terms of the key takeaways that we have learned from this, these are the metrics of what we've achieved so far. 160K users, 1 million interactions, but important to design with integration interoperability in mind and build for sustainability from the word go and leverage vertical funding to invest in digital ecosystems. Starting from below, we got digital funding and we're able to compare with the Ministry of Health and be able to make it sustainable, scalable, and spend on the user's needs. I'll pause there for any questions. Okay, thank you very much.
Great. My name is Samuel Kanga. I'm a technical program manager working with Medtronic Labs. And today, take you through the FHIR showcase, where we shall share our first approach to FHIR adoption for the SPICE platform. So in our presentation today, we'll guide you through the overview of SPICE as a platform, why we adopted FHIR, the phases that we went through, as well as a number of insights that we derived. To start with, SPICE is a comprehensive digital public good for integrated longitudinal primary care. And among the things that it supports is risk-based longitudinal management, bidirectional linkage between the community and the facility, clinical decision support at different tiers of the health system, population health dashboards. It's FHIR compliant, and it's also a DPG as well as global good for health. So the part of the reasons why we adopted FHIR, one is to enhance the platform's interoperability to exchanging health data. And in a number of the countries where we work in, FHIR has been adopted as a standard, and so it was also for purposes of compliance, and also to enable the platform to support the WHO SMART guidelines, last but not least, as compliance to the global standard. As we know, FHIR has moved to become a global standard. I'll invite my colleague, George Bush, to take us through the approaches that we've taken as we adopted FHIR, and we'll get more of the insights we got from this. Welcome, George.
Okay, thank you so much. I hope I make it within the 5 minutes. So the other approaches, okay, let me just see. Okay, nice. So I know de- developers will have, let me just use this. Yeah. Developers will have a question on whether, I'm native, I've never had an experience of fire, will I be able to deliver? So I hope after this presentation, I'll be able to answer you, and I hope the answer will be yes. So we need to understand the trade-offs between approaches and our fire adoption timelines. So in 2022, we started the first release of fire, of Spice, sorry, that was without fire. So we took a first approach where uh, around April of 2022, because of the need to integrate with some of the systems, we needed to have an integration platform that would enable us to do this. So that is when we started the first approach by having the Fire adapter release. So with this, we were able to integrate with the client registry. And then, with development work or with the needs of users, with the needs of saving lives, you will never get a time where you are comfortable and able to just use your system seamlessly. With that, there came a need to integrate with the WHO smart guidelines. We could not do this with the adapter. So we needed to move forward and move to version 2 of FHIR, which was our hybrid architecture. So with version 2, we were able to do two things. Move to the hybrid architecture, and then two, have more modules into our application. We were only focusing on NCD, but with the WHO smart guidelines, we also had the ANC smart guidelines coming in. So the pros that we had with the Fire adapter was the seamless integration of existing systems. We had a selective data transmission to the adapter for external system needs and the efficient data management in both SPICE and external systems. The cons that we had on those is the high development effort required and the construction of all components. Higher initial setup cost due to the building of necessary components and the limitation in leveraging WHO guidelines. The hybrid, we're able to retain our business logics, leverage on the Happy JPS server, and convert the FHIR resources to our business logic. There was also ease of leveraging the WHO smart guidelines, ease of transitioning to FHIR native quickly, and all the business logic were. So just a short, the key takeaways was we had to allocate the appropriate time for the resources, assess architectural trade-offs, invest in training and FHIR community in the FHIR community, and also investment of the value and standards. Thank you.
Good evening. My name is Roy Munge from Honor, and we're going to explain to you about our application, OpenSRP2. And essentially, our problem statement, why we're using FHIR, is the fact that the original version of OpenSRP2, for us to implement projects and solutions for different workflows, we had to copy our code base into a new repo and make some few changes for that particular workflow to work. So having to do that is repetitive and tiring, and we leveraged FHIR and implemented a FHIR native application using that's built on top of the Android FHIR SDK and Android FHIR SDK. So essentially, OpenSRP2, you can think of it as a platform to implement health applications that are mobile-based, and they can be adapted to suit different use cases. And how you do that is through using FHIR artifacts to implement that, as opposed to updates to the code bases. And we have been able to implement different use cases, including community health, immunization, NCD, HIV, supply monitoring, mental health, ANC and PNC, child health, among different others. And the backbone of our application and essentially really thinking about this when we talk about DPIs is that as much as OpenSRP2 is a mobile platform, the rest of the platform, the rest of the components it relies on have been implemented by different teams that are represented here. So all the backend of our solution is a FHIR data store that can be used to do integrations to different other applications, plug into national health ecosystems, and provide interoperability out of the box. So the main reason why it's essentially why the Open Health Stack and the Android FHIR SDK, which OpenSRP2 leverages, has been implemented, is to be an L4 artifact that can consume L3 artifacts to implement health applications. And what this, by and large, means is that when we utilize different FHIR components, then we are able to drive an application. And what some of these components include data capture, and so we can utilize questionnaires, basically being able to collect the data, implement the forms to collect the data, process that data through FHIR artifacts called structure maps, and then provide workflows that will help us implement these healthcare schedules. And so essentially this is just an example of how this would look like. And the application has been implemented to be able to render all these artifacts, provide these workflows, and give visual cues to health workers around that. And this is an example of the simple configurations that will entitle that. And on top of that, some of the added values value adds for this application include the fact that it can support multiple languages, it's offline fast, you can share data between two devices in offline settings, it has a geo widget to help the health workers plan their work. And we're going to just do a very quick showcase of how we can drive these workflows through configuration.
Hi everyone, Benjamin Mwalimu, Technical Project Manager at ONA. So what you're seeing here is what a software engineer would have to do. Instead of writing code, they would have to change configuration files that are stored as binary resources in any FHIR store. And those configuration files determine how your UI looks and how you fetch your data. So what this is showing right now, we're trying to add a new register to list people who have been screened for diabetes in the last 3 months. Yeah, please speed it up. Okay. That's fine. Yeah, and that's what you get at the end. Please come see me.
Cool. So my name is Aisha. I am from Open Function, and I'll be talking about this case study that we did for our Indonesian partner on a non-FHIR to FHIR integration. So before I dive into the case study, I want to talk about what Open Function is. It's an integration platform. It's a workflow automation platform, and I want to talk about Open Function in terms of the full stack approach and the 4 concepts of full stack. So Open Function is an open source digital public good and global good. It can be used as a data exchange building block, and it can be used in any health information system in the architecture. And it also follows different standards and can be used as an integration tool to convert any application into a FHIR standard. It also supports the open content concept of full stack approach by enabling other applications to interoperate, and also has publicly available documentations and resources available from different integration use cases. Okay, so on using Open Function, we have a lot of adapters that will help us connect with different applications, be it FHIR or non-FHIR. But as long as you have an API, you'll be able to connect with any applications. But we've built these pre-built adapters that will help you quickly connect your applications to Open Function and to other destination applications. When we zoom into the FHIR adapters, we have this generic FHIR adapter that you can use to connect to any FHIR server. It does basic authentication for you, and it also will let you create FHIR resources based on your specifications. We also have this custom FHIR adapter that you can create based on your custom FHIR implementation guides. We also plan to support the new FHIR versions as well in our adapters. And you can scan that QR to get to our adapter documentation site where you can get this list of adapters. So let me jump into the case study. So the problem that we were trying to solve was the government of Indonesia had mandated all health facilities to send their patient records to FHIR-based Satu Sahat. And our partners, Asri Clinic, were using Comcare as their EMR. And the problem was that they had to send to a FHIR-based shared health record. So the solution that we provided was created an automated data exchange using Open Function. So as you can see, this is the platform for designing your workflows. You can drag and drop these different components of the workflows, and it's a very low-code platform. But we can provide you a demo outside. I'm not going to go into details of it. But basically, the solution that we provided was created a workflow that gets their cases from Comcare, does some manipulation, and finally posts it to Satu Sahat in a FHIR format. Just some key insights and future plans around this. We are going to be recently releasing this FHIR project for the Satu Sahat. And we've built an adapter for Satu Sahat that any health facility can use to integrate their application or any EMR with Satu Sahat. And so we've done a lot of groundwork for that. There's a lot of documentations, but we're going to be building on that documentation so that it's publicly available. So what's next is we plan to train the ASRI team and have them go live so that they can easily maintain this product or workflow that we've built for them as the Comcare and the Satu Sahat implementation guide evolves. We also plan to have this publicly available, this case study publicly available for other people who want to integrate from a non-FHIR app to a FHIR app. We'll have the processes, the steps that we went through publicly available for anybody that wants to use this as well. And we also plan to advance a lot of our FHIR adapters. Yeah, and you can get documentations for the FHIR adapters there as well. Yeah, that's it for me.
Good morning, everyone. Good evening, everyone. That was a bad start. Good evening, everyone. I'm Brian Amolo. I'm a software engineer at IntelliSoft. I primarily solve interoperability and data exchange problems. So maybe you could start. All right, so my presentation is titled building FHIR native applications using smart guidelines and open health stack. So I'll first start by introducing what OpenChanjo is. So OpenChanjo is an immunization registry that we have built at IntelliSoft. So basically what we aim to do is help clinicians, the clients themselves, and everyone in the health sector to manage immunization records for patients all the way from birth up until hopefully when they die. So it's designed to support both routine and non-routine immunizations. So here I have some diagrams just showing how the application itself looks like. Sorry. Yeah, so you can see a couple of the things the application is able to do. So, I'll get to how we built the application itself. So as you can see, I think all of us have seen this diagram by now. So I don't think there's an official Smart Guidelines logo, but then this just shows some of the standards that we built, we used to build OpenChanjo with. So first there's FHIR, of course, then there's the Open Health Stack, and then the WHO Smart Guidelines. So, so first, what we did was to adapt the immunizations guidelines into to our Kenyan context through the help of the Ministry of Health. So these are a couple of what existed at the moment or at that time. So this is the yellow book. You can see the mother patient booklet. So we were aiming to digitize this using FHIR. So the first approach was definitely to so we start from L1 up until L4. So the first approach was to first create the narratives. Then we went on to creating the DACs, and then the machine readable guidelines. So on my next slide here, you'll see I have just a snapshot of our 5 implementation guide that we used. So this is where we documented all our artifacts, so questionnaires, plan definitions, value sets, and everything that we used together to bundle our application. So how did we build with Open Health Stack? So there are a couple of components within OpenChanjo. So first is the provider mobile application. So this is what providers majorly use at the point of care. So this was built primarily using the Android Fire SDK, and I'll share, we use the data capture library, as well as the structured data capture to capture records. So basically what we do, we take the questionnaires that are already documented within the IG, and we're able to execute this within our devices to get some of the forms that are displayed. Sorry, I was not moving this slide. Yeah, so another aspect is the web application. So we have a provider-facing and a client-facing web application. So the provider-facing web application is not Open Health Stack based, but is able to do many of the same things, but it's custom made. Then we also have a client-facing application to download the certificates and also to enable you to see your immunization records. So another critical component that we built within our application or we utilized was the info gateway. So this is just to restrict access and provide a secure way for both clients and patients to access data from the FHIR server where we store some of this information. Another key thing to highlight is FHIR Analytics. So all of these are components within the Open Health Stack, and we've heard about them in many meetings and the previous presenters. But then we all understand how complex it is to query FHIR data. So we also use the FHIR Analytics to do a couple of things. So first of all is to make our data queryable. Then we also use it to generate a standard report, that is the MOH 710. We also use it for visualizations and dashboards. So this is a sample dashboard from OpenChanjo. Then we equally use it for defaulter tracing. If you'd like to understand how, you can find us at the desk, but able to determine patients who've missed the immunizations just by calculating the data we have from the FHIR server, and then we're able to relay this back to the patients. So this is a diagram of the MOH 710 that we generate. Yeah, so the key takeaway is smart guidelines, FHIR, and Open Health Stack. They provide you with a robust framework to develop innovative healthcare applications that can seamlessly integrate with existing systems.
Okay, one moment. My name is Patrick. I work at UW Digi. And there we go. Thanks. Oh, there we go. Okay, cool. Okay, cool. Now we're ready. So I guess the main problem that we're trying to solve is the problem with JSON formats, right? With FHIR, as some of our colleagues mentioned, it's excellent at storage, it's excellent at capture of real-world data, and it's human readable. Like anybody can sort of read what this is telling us in terms of the patient. but it is harder to retrieve data, and it is an analytics burden when it comes to needing to parse an entire tree. So we use Open Health Stack FHIR pipes in order to basically go in 3 steps: flattening the tables using either Spark SQL, SQL on FHIR v2, or WHO Smart HIV CQL guidelines, performing dimensional data modeling on those flat tables, and then plugging that into reporting and dashboards in both Zimbabwe and Cote d'Ivoire. So here are some pros and cons for the table flattening methods using both Spark SQL, SQL on FHIR v2, and WHO Smart CQL. You know, SQL, for example, has perhaps the widest capacity and knowledge base of any of these methods. But still, the indicators can be operationalized many different ways, so it may be a little lacking in comparability. SQL on FHIR v2 has standardized FHIR path expressions for extracting data, but there still needs to be an expressive query language to integrate data among multiple resources and sources to build your fact and dimension tables. WHO Smart CQL has operationalization of data done through expressive CQL, but again, you need to sort of conform to a common data model when it comes to using CQL. Oh, sorry, you guys didn't see that. So when it comes to dimensional modeling, what are sort of our best approaches, considering we're using sort of the same base data model, FHIR in this case, and how these should be reproducible across various settings. So here's an example of our dashboard in Zimbabwe. And a question I want to posit all to you is, how do we move beyond funder-driven reporting to a more dynamic data use strategy in these settings, and how do we encourage data exploration and curiosity? And you know, this is an example where we can cut the data for FHIR here across various demographics and disaggregations like locations and time. And so here's an example of maybe a strategy that we're able to use to be able to like really pinpoint and drill down to be able to see like where we have performance issues here, in, for example, in this District 51, and compare that over time to say, you know, unlike the general trend where loss to follow-up is decreasing, loss to follow-up in this geography is actually increasing. I also wanted to present something that my colleague Moses did using the same FHIR pipes. It was actually using a FHIR-to-FHIR sync to be able to move FHIR data to a more centralized locations using a FHIR-based EMR and also a FHIR-based OpenLS, which our teams are also the stewards of to be able to basically integrate and centralize the data into a FHIR SHR. And I wanted to end this by saying we're trying to develop a community of practice around analytics, so feel free to scan this and join. Thank you.
Good evening. So I'm Dragoș Dobre, IT System Architect at Swiss Tropical Public Health Institute. And this afternoon I will talk to you about health insurance and FHIR. I might be with Uwe, the only ones working on health insurance and social protection. So we develop and implement OpenIMIS, an health insurance and social protection solution, which manage enrollment, health service, claiming and reporting workflows. So basically, when we implement OpenIMIS in different countries, we encounter different issues, especially because there are so many tools there, domain-specific solutions, and the problem is that those information which is in different systems, because you have the EMRs where you have encounters information and service delivered to patients, and you have an OpenIMIS claims which takes the same information. Basically, there is an issue actually to inefficiency and increase the risk of human error because you need to copy from one solution to another solution manually. It's also a process which is actually time-consuming, and it's also resource intensive. So our proposal solution is actually to integrate those domain-specific tools with OpenIMS using FHIR. So we did implement it in OpenIMS, a FHIR API based on the FHIR 4. And this integration, basically, we reduce those redundancy and improve accuracy. Basically, also improving the response and payback to the health facility of those services that were provided to patients. So basically in Cameroon, initially there were up to 6, 7 different implementation of OpenIMS based on different programs. For example, HIV, tuberculosis, voucher schemes for maternity. Lately with the national USC bill, so we did integrate those programs in one unique implementation of OpenIMS in the country. And in the same time, within their national architecture, they decided to use another platform to do the pre-enrollment of the different population. So this platform is called Cameroon Health Coverage, which register all the citizens, and this is a platform which assign unique identifiers to all the patients later on. Basically, the role of OpenIMS in this context is to actually manage claims, so to do the enrollment to different programs, as I mentioned, HIV, tuberculosis, voucher scheme for maternity or others, and also to manage the claims which for the services that were provided to different patients within the country. So those exchanges will have been integrated through FHIR, as you can see, patient coverage resources, and especially for the actual claiming. So we did integrate a specific platform called DAMA, which managed HIV patients because, and especially of the anonymization of the patient information, which was not, should not be present within OpenIMS compared to the other programs, which you need to have personal information, basically. So that platform was separately integrated as such. Unfortunately, due to decision, which is not on our, cannot say anything, this platform basically later on after we started, it was completely disconnected and that is not integrated anymore. So currently there is specific applications of OpenIMS for this claiming right now to say it is HIV program or it's all the other programs which actually provide specific and user patient information. So currently there are other platforms which are in progress to be integrated. So I can mention here BACME for the claiming, OpenCRVS as birth and death updates information, and also master facility GovFHIR. And I didn't include it here, but also OpenLMIS will be soon also considered. And thank you.
I'm Chris Ihure, data engineer from PharmAccess. At PharmAccess, we specialize in doing small experiments at minimal scale. I think from most demonstrators here or implementers, you have seen that most of these are being forced or at least being pushed by governments, but for us, we wanted to see how we can do this from bottom up and focusing on probably the patients. There are some questions that we probably have, whether the patients do understand the item of consent, and if they really want to share data. And also I think questions that had been asked earlier during the conference was does indeed sharing data lead to better outcomes? So for us, what we are looking at is how we can improve our mother's journey by improving their, by sharing data. And this is by trying to adhere to the WHO ANC guidelines. And by this, we are trying to follow a value-based sort of system where we try to maximize the utilization so that we can see if this will, if we can maintain the high quality while still doing it at the same cost. How we are doing this is by including a telehealth. So here are the WHO touch points that are recommended. Some of them are physical and some of them have been made to be virtual. So where FHIR comes in is that we are trying to connect three stakeholders. One is a virtual a virtual provider, which is HealthX, and then a claim processor and physical care. And FHIR was able to resolve this issue for us. So we are using the OpenHIM architecture and also as our conductor. And as some of the, what do you call it? Some of the approaches that we saw, for us, we are using mediators to be able to convert data from, let's say, the claims management system, put it to FHIR, and then for the remote healthcare, they're able to consume it in FHIR format. For the physical, we are able to pull their data in their format, convert it to FHIR, and then share data even for claims management. So that's how the data moves. Sorry. So our learnings, as I had said earlier, first is we also had to first understand if indeed patients understand the concept of data sharing, because mostly this is being pushed from up, but do patients really understand what that is? So we saw that they are receptive to it, and then the other benefit that we saw was being able to create pipelines. Once you already know the FHIR data structure, you're able to automatically generate government reports, which helps the facility in reducing their turnaround times. The other learning that we have had is the difficulty of trying to sensitize facilities, why they need to actually share data, and also the patients, why they need to share data. And also there is also need for sensitizing probably why FHIR is being chosen by the government, because I think this has been something that has not been done, or at least has been, so it has been lacking in the Kenyan system, whereby most private facilities have not been engaged on why we need to do that. Yeah, I think that's it for us.
All right, good afternoon, everyone. My name is Trezor Vumbi. I'm the software developer manager at Gembi. So I'll be talking about our recent experience building FHIR compliant system or FHIR compliant HI in general. So now go move next. All right, cool. So it's one of the things that we learned over the year of implementing health information system is that building health information system is really hard, right? And there's a number of reasons for that, because obviously you're building a system that needs to scale at either national or provincial level. It needs to be secure, because we're talking about highly sensitive clinical information. You need monitoring in place and many other things, right? And over the year, what we started really learning or observing into the ecosystem is the same solution or the same problem trying to be resolved over and over over the time. So in the last couple of years, we've been focusing more on how do we stop that, right? How do we try to not building the same solution from scratch? So that's really where, oh, I need to move to the next one. And then again, moving on, so I want to start by the journey that started with OpenHIM that has been presented a few times here, which is a health information mediator. So the idea here was to build that interoperability layer and then to keep it as lightweight as possible with the focus on the main interoperability capacity, like your security, authentications, or traceability, etc. And then leaving the possibility to build what we call mediator that are represented there in red, which are essentially custom microservices. There can be also existing digital public good that can plug in into the HIM to do more of like transformation into FHIR or anything else. And then moving on, if we zoom out a little bit and then look at the OpenHIM, at the bigger OpenHI architecture, it is currently sitting at the middle of at the layer of the interoperability layer, but we still have all those other components that still need to bring to have a fully complete HI here, right? So that the problem we wanted to solve, to focus on how do you have a base system that helps you to spin up or deploy all those components without reinventing the wheel over and over. And then that's actually what led to the next project that we're currently working on that we call the OpenIM platform. It is really like, you can think of it as a set of components that can be reused and deployed in like a very simple way, right? So it's all those components, your toolbox, but not only a toolbox, but also the glue that kind of links all those components together so that you can have a set of components that work together to deliver some business value. And the next step is that all this platform is built on another digital good technology that is called the Instant Open HIE. That Instant Open HIE offers you a CLI tool that allows, first of all, to give a very clear specification on how you package all your different HIE components, but also with tooling to deploy and then manage all your components. So this is just an example of one single line of command that can allow you to deploy like an interoperability layer, maybe a client registry or anything else that you want in just one command and get a fully blown HIE running on a cluster environment, for instance. I'm not going to have a time to demo everything, so I'm providing here a quick QR code if you want to scan and have a quick short video that shows how this entire platform works and a few documentation. And then the last thing before I go is that we're trying to build a community around all this because we've seen a lot of cool technology here. So this platform allows you to package that in a way that can put it in the market that is free for everyone to join and then start using. So you're more than welcome to come and contribute with the awesome tool that you're already building. Thank you for your kind attention.
Hello, I'm Grace Potma. I'm Director of Product for OpenMRS Inc., which is like a foundation that supports the worldwide OpenMRS community. And my colleague Moses from UW-Digi, since we are a community of different organizations, will also be available after. We'll have a table for any questions you have after this presentation. So if you don't know what OpenMRS is, put your hand up if you've heard of OpenMRS before. If you have heard of it, okay, 50-50, great. So OpenMRS, open source medical record system, it's literally in the name. It's for low resource settings, and it's maintained by a global community. We don't have a big HQ anywhere. So what I'm going to share with you today was built by our global community. So we are all over the world. It's live in over 80 countries. And OpenMRS has been around for a while, but we have a growing problem that we wanted to solve. Increasingly, people around the world are saying, hey, guess what? The medical record is not the only thing in this hospital. We also have labs and imaging and other studies and resources that we need the EMR to know about. So we wanted to solve that problem consistently rather than having to keep integrating from one thing to the next thing to the next thing. The second problem we wanted to solve is that e-health leaders and ministries are saying, hey, we've got all these great services we want to connect to. So we thought FHIR will help us solve this vertical and horizontal integration. But we had a problem. You see, OpenMRS's data model was created long before the FHIR data model was created. Uh-oh. And you can't say to the 80 countries around the world using OpenMRS, hey, guess what? You want to change the most complicated part of your product? Not going to work. So we needed an approach that would be really practical. We needed an approach that would not require a big backend switch. But fortunately, there was some helpful overlap. You see, it just so happens by design that OpenMRS and FHIR both have a similar way of approaching the world. You've got your way of storing your data, and then you've got your way of labeling what it is, your dictionary. So that's been helpful for us. So a bit of an explainer here, we decided to build a FHIR module. This is like a plug-in add-on to an existing OpenMRS database. It needs to be reasonably up-to-date, but within the last few years, which most people are by now. And then we just mapped things. We said, okay, here's the OpenMRS data model for conditions, and what is it in FHIR? Let's map those. This module plugs into your existing OpenMRS system, and it also creates an OpenMRS FHIR API. This means that whether it's the front end, the face of the application, or whether it's a government system, or whether it's a lab system in the same hospital, they can all talk to the same FHIR API if they want data from the OpenMRS brain or database. And it's working. So my emoji flags did not work properly, but these are some of the country codes where this module is being used in production for real-world data exchange in the last 2 years. So for example, thanks to a lot of work done by our colleagues by Digi, they've got live connections working in several countries now at facilities with things like lab information systems like OpenLS, as well as OpenCR for national level MPI queries and client registry queries. But we're also seeing a lot happening right here in Kenya. And if you're staying at GDHF and you're going to some of the site visits this week, you will probably see this for yourself at some of the sites. If you hear that they're integrating with the terminology registry or the lab system or a data dashboard, that system, if they're based on OpenMRS, if it's Kenya EMR, they will be using the FHIR module that I just shared with you. Okay, moving forward. FHIR IGs. We've heard about this a little bit this week, and this is what ours looks like. As you saw yesterday in Jing's presentation, you don't need a ton of resources to start using FHIR. We said to ourselves, should we try to do all of the things? No, we've prioritized it based on what was actually needed. So for example, the medication dispense resource, we just added that within the last year because one of our organization's partners in health needed that for a project in Sierra Leone. But this is the real magic of a FHIR IG. I love this story from our colleagues at Digi who found that because of their work on the FHIR IG, it has dramatically improved the turnaround time to integrate two systems that both support FHIR. We're talking from 6 to 8 months to do a custom integration to 2 to 3 days to connect those systems using FHIR. That's a really dramatic difference. So what's next for OpenMRS and FHIR? IPS. Again, thanks to our colleagues at Digi, we've got some preliminary work on IPS, and we hope to dive deeper into that. If you have any questions or you want to learn more, here is the short link to OpenMRS's FHIR 101 page where you can learn more about our strategy. And our colleagues around the world from multiple organizations just published a really great paper explaining all of this in more detail. Thanks so much, everyone.
Good evening. My presentation is entitled Delivering Health for All. It will be a case study of the electronic community health information system in Kenya. It's built on the community health toolkit, open source digital public good. We have open access resources, budding and growing community, and open source technology that is used to build tools for community health workers to support them deliver care the last mile. So this is the coverage and reach of the CHT. Stats are slightly dated. This is as of March this year. And these are the use cases we support in community systems that have implemented CHT. But these specifically for the Kenya community health space. Once you collect all that data, we support government with visualizations. And these are some of the stats. Once we deploy the technology across the country, one key thing emerged, like how do we facilitate the continuum of care from community to facility, especially in the digital age. The healthcare system in Kenya is modeled as such, as a primary care network. This is a hub and spoke model with a referral facility at that level. It's called level 4, and level 2 and 3s in between the patient and the referral facility. Now, in the digital age, we have technology empowering CHPs between the community and the first level of the facility. So we had to figure that out. How do we solve for that? And oops, nothing, okay. There's a nice diagram that should have appeared here. Our approach was to use OpenHIM and mediators, where on the one side we have a list of CHT instances, one for each county. And in reality, you could have different implementations because different counties have different health needs. Now, with that, you have mediators to translate each of these specific requests into a FHIR that is stored in a shared health, a FHIR server for consumption by EMRs. So we ended up using service requests and patient resources, because our key use case at this point in time was ensuring all referrals are represented and delivered to facility, and eliminate the use of paper in referrals. And for every interaction that happens at the facility, getting recorded against the patient's shared health record for onward delivery to the community. So, some of the lessons we learned in our journey, like government commitment is very key in this. The leadership in defining the registries that should exist, the standards that the Kenya health space should adopt is key in aligning all implementers. And on top of that, collaboration between all implementers ensures that the adoptions are consistently adopted and utilized to allow the ecosystem deliver the impact that's needed to the patients that we serve. For the registries, we have painful lessons on the challenges of data quality. And in our adoption journey, all these things were happening in parallel. Registries were coming up, they were maturing as the ecosystem was adopting FHIR, adopting interoperability. So we've been iterating by the day. Terminology definitions are key. FHIR on its own isn't the solution. You need to ensure you're defining the same thing for everyone. So terminologies that are shared across the space is critical. And also, something very interesting is your FHIR might not be my FHIR, where it's just a protocol. So we all need to ensure that consistency. And the last bit is for us, we work in very remote areas where connectivity is a challenge. And balancing that expectation of facilitating referrals in the digital age is a bit tricky, because some people can go for hours or days without connectivity. So how do you balance that? It's an open problem we are still solving for, and I'm happy to hear any lessons people have learned along the way to solve for that. Thank you.
Right. Hello, everyone. My name is Almazida, and this is my colleague, Fabi. We're both from Summit Institute for Development from Indonesia, and we're here to present you about how we implement the FHIR ecosystem in Indonesia to integrate the primary healthcare. So if you never heard about us before, SID is a local NGO in Indonesia with a vision to improve our public health and human development by integrating and strengthening the primary healthcare. So just as some of you have known that most of the primary healthcare in Indonesia are still somehow scattered, while it's still provider-centered, and most of family members must seek out multiple providers that are not linked and scattered. And our ultimate goal is to make sure that the systems is actually person-centered. So whenever you go to every facilities, your data is actually connected. Your data is actually up to date. And the PSG services are still fragmented in Indonesia and still having a lot of disparities in the care quality. And most of the facts is actually because of the lack of the data interoperability and also the underutilization of the data. So most of the primary care actually retrieve the data, but never actually use the data to take action based on that. Most of it is just for reporting. So the MOH of Indonesia is actually asked us to create a piloting project in Indonesia in one of the districts is in Gabut, where we want to accelerate the integrated primary health care. And this is what we really want to achieve, is where the person-centered team-based care are performed, where we making sure that we compile all of the informations into the FHIR servers to make sure that all of the facilities have the most up-to-date and complete patient data. And this is our approach. So the first, we make sure that we acquire all of the informations from every of the systems, including every of the apps that have been developed before, like the paper forms also, and many community healthcare forms, making sure that we retrieve it daily. So whenever every of the facilities may not have the FHIR native apps, we still are able to make sure that we retrieve all of the data. So making sure that the complete data is included in our FHIR systems. And we also have some FHIR native apps to take the data. And most of the data that might not be FHIR native, we make sure that we convert it using the FHIR implementation guide and making sure that it also conforms with our national standards, which is Satu Sehat. And in the processing, we make sure that all of the data duplications is actually completed, is actually clean. So whenever we have two data of the patients that is from similar kind of facilities, making sure that the duplications is sorted, and we also make sure that we upload it to our national health information systems. And at the end, we want to make sure that we automate it for making sure that data can be utilized to take action. Okay, this is the 3 of our apps co-created with ONA. This is the midwives, for the carers, and for the vaccinators. So we created all of this app together with ONA based on the OpenSRP 2.0. So we make sure that all of this app is actually synchronized and kind of interconnected between each other. So let's say that you are a midwife and you recorded the ANC care of a mother, so the carers or the community health workers actually know that you already completed those ANC care. So it makes sure that all of the persons in the ecosystems knows you're up to date and making sure that the completeness of care is implemented.
So we all agree that FHIR is a beginning of a really great healthcare system, but we can't forget how we utilize after. So we have this kind of encounter ecosystem where all of the data collected and entered into a digital form and a FHIR-based app compiled into one server database, and it is used to utilize those data as a dashboard, followed up by call center and WhatsApp API, and also automated visit and live tracking. Oh. Okay, so how we utilize those data? We make sure that all of the data we get from the primary healthcare get back to them, because we want each of the primary healthcare we work with have access to those dashboards so they can take actions directly to any problems they have. Also, we have data integration and actions to close individual care gaps. For example, we automated the WhatsApp reminders for every time, like a pregnant woman need to have a visit or they have any care gaps, they will receive a WhatsApp reminder. And then, beside the WhatsApp reminder, we also have these call centers where this agent will actively call those patients if there is any missing cares they have, and make sure all of those contacted will have completed their visits next time. The last, we also have this name dynamic worker support, where it provides automated job scheduling, route optimization, and also real-time support for all of the field workers. This is the example of how we monitor the field workers daily. It is a map where we can live track any of the field workers, and the operators who work behind will able to help if any of them have problems. This is the interface of how they can see the jobs they have in the morning, so they don't need to think like, what should I do today, but they all have all of their tasks, and the route will be optimized, so it will minimize the time cost. Also, we mentioned previously that each of the data we get from any healthcare would go back to them. For example, like completion of vaccination status. If there is any gaps in there, we want that each of those healthcare take actions directly, so we want them to have direct access to our dashboard. So we have covered like 10 districts in Indonesia, and we also want to cover more districts in the future. And also we want to enhance our dashboard with FHIR analytics. That's one of our future goals. I I think that's all from us. If you have any questions, feel free to reach us and visit our booth. Thank you.
Thank you, everyone, for your attention. As you can see, we've seen a multitude of examples of how FHIR has been used to solve specific challenges and gaps. And I really encourage you all to spend some time visiting the product demo sessions, which will be held just soon after we have the dinner, and exchanging and having discussions around what you just saw today in a snapshot. I will now pass it over to Chinny to say some closing words for today.
Sorry to disappoint you. I'm not saying closing words for today. I just want to, before we introduce Mr. Ryan Dos Santos from the WHO Euro Regional Office to do the closing, just a short announcement for the WHO Regional Office and Country Office teams and Ministry of Health country teams. Can you please wait behind for 10 minutes after the session closes? And we will have a short announcement on a gala dinner that's happening after the meeting. We would encourage you guys to please join us at the gala dinner. So I'll hand over to Ryan, who will do the closing.
Thank you, Chinny. Hi, good evening, everyone. You all look very, very tired in this very, very long day. And I would just like to, first of all, start out with asking you a question. I know you've had enough and you're probably loaded, but I want to know from you, from some volunteers in the audience, what are your takeaways from the day? What did you really enjoy? For me, I will share mine quickly. I had in the track 2 a very interesting discussion with my colleagues from Latvia and Lithuania. In the actual working group session and very fruitful discussions, and I think that was amazing. Hearing the work that they're doing and also hearing their plans in moving forward and in actually adopting and adapting what they've learned in the past 2 days. And for me also, the demo that just happened. And I would especially like to note something. As an older guy, as my son would keep telling me, the young people who are taking the lead on this, we saw many of them on stage this afternoon, and I would ask you to give the young people who are leading this charge a round of applause, please.
Yeah.
So it's amazing, and hats off to them. I've met a few of them and had discussions with them, and it totally blows my mind the way that they're thinking. Awesome. So putting it out to the audience now, and Fred is there with the mic.
Thank you very much. So, yeah, my name is Wande from Ethiopia. So, takeaway from today's session was, mainly we just have a cocktail of e-health systems with FHIR and the smart guide. So, that experience means a lot for the participants. So, we learned a lot in terms of just, implementation. And we do have also a lot of experiences in terms of, FHIR customization, adaptation to the local context. So that is very interesting portion of it. So we learned a lot. And then for the sake of Ethiopia, I think we need to also customize in our context in EPI. So for the future, we will have one scenario just to present for this session. So really appreciate what you did. In terms of just sharing this kind of cocktail. Thank you very much.
Thank you very much.
Thank you. Any other reflections? Track 1 or track 2? Yeah.
My name is Olegas. I'm coming from Lithuania. I have a very short reflection. Basically, this last session, all these great examples of this fantastic application gives such a huge inspiration. So I remember one phrase of one smart guy from Europe who said, in Europe we do a lot of think tanks, and it's time to make do tank, right? And that was a great example. So much good things are done, and you all guys, a huge inspiration. Thank you so much.
Thank you.
Thank you. Anyone from track 1 want to share something, please? Can I get? Told you I was coming for you.
Thank you. Mine is basically, oh yes, Eric Maira from the WHO Kenya Country Office. Mine is basically on Gen AI, the generative AI. It's quite impressive how far it has come. And I actually believe that it can be used for good, for health. And just using the Gen AI and seeing how well it can respond to real life questions, it's quite really impressive. Thank you very much.
Thank you.
Thank you.
Any other takers? We'll take one more.
One more, last one.
Yeah, so my name is Al Hassan Mai, the country coordinator for the Digital Innovation in Pandemic Control, a global project being implemented in 5 countries. So for today, my big takeaway has to go with the prompt engineering and the generative AI session. It's strategically aligned with my career pathway, so I enjoyed it a lot. And I've already tried to see how best I can initiate connections with those that led that particular session, because it really touched my life, and I think I'm going to cascade it to my country. Thank you.
Thank you very much.
Thank you.
So I would just like to say in closing, to the colleagues who just shared their experiences, thank you very much for that. It's great to hear all the positive outcomes of this. To all our speakers and our panelists, thank you all so much for today. It was really great content, really great information, and as you've heard from our audience, is well received. For everyone here, thank you all for being here. And I would like to say thank you also to the team who is making all of this happen.